Hello, in this video I'm going to show you how to configure, connect and inspect the PR electronics transmitter model 5333A. It is a 2-wire programmable temperature transmitter commonly used for linear temperature measurement with 2 or 3-wire RTD sensors. It converts the RTD signal into a standard 420 mA analog current output suitable for PLCs or other receiving devices. The transmitter is designed for mounting in the Form B sensor head or on a DIN rail using additional fitting. To use the device, first we need to set the correct configuration for our sensor type and application. For this we are going to need USB to transmitter communication interface called PR loop link. We need to connect one side to the PC USB port and the other side to transmitter's power supply pins. Red wire goes to pin number 1 and black wire goes to pin number 2, just like so. When everything is connected, we can open preset software on the computer. This software is free and available on manufacturer's website. So first we need to make sure that correct COM port is selected, and we can press receive button in order to receive the current device configuration. So okay, you can enter a tag number and select the right sensor type and temperature range. If 420 mA output is set, we will receive 4 mA when there's 0 degrees and 20 mA when there's 50 degrees Celsius. Check the correct output, set to 420 and press transmit to overwrite the device configuration. And press OK. That's it. When the configuration is done, we can connect the wires. Power is supplied to pins number 1 and 2, with the positive pole connected to pin 1 and negative to pin 2. The supply voltage should be between 8 and 35 volts DC. Typically the voltage is supplied directly from the active input of the PLC, but in case of a passive input, an additional power supply unit is needed to power the current loop. 3-wire RTD sensor is connected to pins number 6 and 3. And the cable compensation wire is connected to pin number 4. In case of a 2-wire RTD sensor, you can just add a jumper between pins number 3 and 4. In case of malfunction, you can always inspect the transmitter. First, you need to make sure that the power supply voltage is in the range. It should be between 8 and 35 volts DC. Then, after turning the power supply off, you can check if the resistance of the sensor matches the expected values at a given temperature. If values are way too high or close to 0, it could mean that the temperature sensor is faulty. Resistance between pins 3 and 4 should be minimal. You can also measure the current output directly measuring the current between pin number 2 and the negative supply wire. The current output should match the expected current according to the temperature range in the configuration. You can also check the transmitter connecting it to PC and using preset software. Just click on the monitor button, wait a few seconds, and now you can see the status, measured values and output signal in real time. That's it for today's video. I hope you find it helpful, and if you have any additional questions, feel free to contact us.